This is Ben from Testiv, and we're looking at an SAT Heart of Algebra problem with a system of equations. Now, this question doesn't just ask us to solve the system of equation, it actually asks us how many solutions, points, are there to this system of equations. Now, this requires you to understand what a solution is to a system of equations. It doesn't require that, but it helps. A solution to a system of linear equations, like these, and by linear I mean equations that represent straight lines as opposed to parabolas or something like that. How many solutions are there? Well, what the solution is to begin with is where those lines intersect. It's asking you to solve for that point where the lines intersect. So what would it mean for a solution to have for a system of equations to have no solutions, for example? Well, that would mean that the lines are parallel. That would be no solution. So how do you figure out the solution? Well, or how do you figure out how many solutions there are? What you need to do is, if you're solving for the solution to a system of equations, you can solve for the values of x and y when those equations are equal to each other. So the first thing that we're going to do is we're going to put each equation into y equals mx plus b, slope-intercept form. So let's take the first equation, y plus 3x equals 2. That's pretty easy. That's just going to be y equals negative 3x plus 2 because we're just moving it over. Okay. Second equation, we're going to need to do a little more manipulation. So we can see that everything in this equation is divisible by 3. So let's just start by dividing everything by 3 because we want to have it as y, not 3y. So if we divide everything by 3, we're going to get if we divide everything by 3, we're going to get 2 minus 3x equals y, which is the same thing as y equals negative 3x plus 2. Well, that looks pretty familiar. That's the same equation. So we actually have these two equations are the same. They represent the same line. So if you think about the same line on a coordinate grid, y equals negative 3x plus 2, so maybe something like this. What we're really saying is that there are an infinite number of points along this line that would satisfy these two equations. That is, you could plug in any point along this line and it would work for x and y. So in that case, our answer has to be more than 2.